Yes, Ashok. Any queries? Hello.
नहीं मैंने देखा आपकी आवाज कैसे नहीं
Okay. Is the PPT visible?
सर
Okay. Okay, I think we can start now. Anyone needs some more time? Someone needs to join. Hello. Can we start now?
Yes.
Okay. Yeah. So this PPT is visible, right?
राइट
Yeah. So, good evening, everyone. This is the fourth live discussion on Geotechnical Engineering 1. The topic of today's discussion is soil compaction. Like the last few days, there will be some short questions, MCQs, MSQs, and some numericals. You need to take out your copy, pen, and scientific calculators. I'll first dictate the questions along with the options. You need to write down those questions, and then I'll give you some time, 10-15 minutes, to solve those questions, and then after that, we'll discuss the answers. Okay? So I'll start the questions. If others join, they'll start from the running question at that point of time. Okay. Okay. The first question is the factors affecting compaction of a soil are the factors affecting compaction of a soil are the options are water content, soil type, compaction energy, or all of this. I repeat the question. The factors affecting compaction of a soil are the options are water content, soil type, compaction energy, or all of this.
Sir, PPT.
Yes, PPT. Not visible. What is it? Hello. Who was speaking? Ashok.
आवाज आ रही
Yes. What? If your mic is causing problems, please write in the chat. Whoever was speaking, I couldn't hear you. Please write in the chat if you have any issues. Okay, I'll continue just. This is the first question. The second question is, okay, PPT is not visible. PPT is not visible now. Is it visible? PPT. What is the issue? Okay. Sagar, yeah, the visible. So only icon is there. Which icon? Shakir, then you do one thing, you just leave the meeting and join again. I'll admit you. Then you check once. Okay. For the others, the PPT is visible, right? Ashok, Abhishek, Sagar. Sagar is it? Okay. Okay, I'll just continue. Let him join. The next question is, for a same soil type, the effect of heavier compaction is to decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. If the soil is same, what will heavier compaction do, or a more compactive energy do for a given soil mass? And this is a multiple select question, so more than one answers can be correct.
Sir, decrease the optimum.
And no need to tell the answer now, just write down the questions, write down the options. I'll give you time to solve all the questions. There are some numericals also. I'll give you time at the end of the end, and then you will get some time to solve the questions along with the numericals. After that, we'll discuss all the answers. Okay.
Got.
Yeah. Okay. So the question is, I'll just repeat the question. For a same soil type, the effect of heavier compaction is to. The options are decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, or increase the maximum dry density. After I finish telling you the questions, I'll give you time, okay? 10 minutes to solve the answers. And if you have any doubt, if there's anything causing any disturbance, you can just raise your hand or just write in the chat box. Okay, so this is the question. This is a multiple select question, so more than one answer can be correct. Okay, next question. The water content used in field compaction is known as. The water content used in field compaction is known as. The options are optimum water content, field water content, placement water content, or natural water content. Water content used in field compaction is known as. Repeat the question. Water content used in field compaction is known as optimum water content, field water content, placement water content, or natural water content. Next question. Compaction control in the field consists of determination of. Compaction control in the field consists of determination of water content at which the soil is compacted, dry density achieved, degree of compaction, or all of these. I'll repeat the question. Compaction control in the field consists of determination of water content at which the soil is compacted, dry density achieved, degree of compaction, or all of these. Next question. Vibratory rollers are useful for compacting. Vibratory rollers are useful for compacting which kind of soils? The options are cohesionless soils, crushed rocks, gravel, clay soil. The question is vibratory rollers are useful for compacting. The options are cohesionless soils, crushed rocks, gravel, or clay soil. Next question. Clay particles compacted on the dry side of optimum moisture content exhibit. Clay particles compacted on the dry side of optimum moisture content exhibit. The options are single grain structure, dispersed structure, honeycombed structure, or flocculated structure. I repeat the question. Clay particles compacted on the dry side of optimum moisture content exhibit. The options are single grain structure, dispersed structure, honeycombed structure, or flocculated structure. Next question. Highway embankments on cohesive soils should be compacted on the dry side of the optimum moisture content to achieve. It wants the reason why should highway embankments on cohesive soil be compacted on the dry side of the OMC, optimum moisture content. The reasons, the answers are low permeability, reduced pore pressure, high strength, or none of these. Repeat the question. Highway embankments on cohesive soil should be compacted on the dry side of the optimum moisture content to achieve. The options are low permeability, reduced pore pressure, high strength, or none of these. Next question. Plasticity needle is used to determine. I hope everyone knows what plasticity needle is. Plasticity needle is used to determine plastic limit of soil, penetration resistance to control field compaction, penetration value of bitumen used in road construction, or swelling of black cotton soils. Someone has joined right now, Philip Topal. We just start from the current question. I'll be repeating all the questions during discussion, okay? The question is plasticity needle is used to determine plastic limit of soil, penetration resistance to control field compaction, penetration value of bitumen used in road construction, or swelling of black cotton soils. Next question. This is a true or false statement. Well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soils. The statement is true or false. The statement is well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soils. I believe it will be THAN. The spelling mistake. Well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soil. Is this statement true or false? Next question. This is again a multiple select question, so more than one option might be correct. The variables concerning the method used to compact a given soil include. It means when we are focusing on the method of soil compaction, what are the variables that should be kept in mind, or that is important to find out the degree of compaction. Variables concerning the method used to compact a given soil include. The options are manner of operation, weight of the equipment, area of contact, or time. I'll repeat the question. The variables concerning the method used to compact a given soil include the manner of operation, weight of the equipment, area of contact, time. It's a multiple select question. Okay, next question. Pneumatic tired rollers are suitable for which kind of soils actually? Gravels, cohesive soils, sand, or all of this? If there is any question you are unable to understand or anything you haven't read yet, please raise your hand. Yes, Shakir.
Question.
What?
Two.
I think your mic is causing some problem. You can write in the chat box if you have any doubt. Two questions you need to write. Is this from the beginning of the class where you just logged out of the meeting? First two. Okay, no worries, Shakir. I will just repeat the first two questions for you at the end. Okay. Just keep some space or write the first two questions at the end. Okay. I'll just carry on now. Yeah. So the question was pneumatic tired rollers are suitable for, the options are gravel, cohesive soil, sand, or all of these. Next question. Again a true false statement. The compactive effort in the modified Proctor test is roughly 4.5 times that in the standard Proctor test. Is this statement true or false? The compactive effort in the modified Proctor test is roughly 4.5 times than that in the standard Proctor test. This statement is either true or false. You need to write down. Okay. Next question. The number of blows required for compacting each layer of soil in a compaction test is. The number of blows required for compacting each layer of soil in a compaction test is. The options are 30, 35, 45, or 25. The question is the number of blows required for compacting each layer of soil in a compaction test. The options are 30, 35, 45, or 25. Next question. Among the following, which one has the highest optimum moisture content? The question is among the following types of soils, which one has the highest optimum moisture content? The options are sand, clay, silt, or gravel. Among the following, which one has the highest optimum moisture content? Sand, clay, silt, or gravel? Next question. The line showing dry density as a function of water content in the absence of air voids is called. The line showing dry density as a function of water content in the absence of air voids is called. The options are zero saturation line, no air voids line, maximum compaction line, or saturation line. The line showing dry density as a function of water content in the absence of air voids is called. The options are zero saturation line, no air voids line, maximum compaction line, or saturation line. Next question. In modified Proctor test, the soil is compacted in how many layers? The options are 2, 3, 4, and 5. In modified Proctor test, the soil is compacted in 2 layers, 3 layers, or 4 layers, or 5 layers. Next question. To avoid large swelling pressure under pavements, the soil is compacted. Weight of OMC. OMC means optimum moisture content. Soil is compacted. Weight of OMC. At OMC. Dry of OMC, or none of these. To avoid large swelling pressure under pavements, the soil is compacted. Basically, on which side or at which region of the MDT-OMC curve, maximum dry density, optimum moisture content curve. The options are weight of OMC, at OMC, dry of OMC, or none of these. Next question. The 95% saturation line and the 5% air voids line are same, different, might be same or different, or same under constant moisture content. Is this question clear? Is there any doubt with this question? Yes, Shakir. If you have any doubt, you can either ask or drop a message in the chat box. Otherwise, it's fine. And continue. The question is, the 95% saturation line and the 5% air voids line are same, different, might be same or different, or same under constant moisture content. Next question. This is a numerical. A soil sample has specific gravity of 2.7 and optimum moisture content of 16%. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? Fourth option meaning not clear of the previous question. Same under constant moisture content. What is not clear? These two parameters, saturation 95% saturation line and 5% air voids line. If the moisture content is same, then these two will be same. I tried to mean that in this using this option. Now, this is an MCQ, right? So if this option is not correct, it might be meaningless. Constant moisture content. Suppose the moisture content is 20%. Okay, if the soil is fully saturated, the soil is 95% saturated at a moisture content of 20%. Then at that 20% moisture content, the 5% air voids line and the 95% saturation line will be the same thing. Is it clear now? Yes. Suppose I try to imply that the moisture content of the soil is 20% and at 20% moisture content the soil is 95% saturated. Then in the MDD OMC curve, the 95% saturation line for 20% moisture content will be same as the 5% air voids line. Both the lines will be the same line. That is, one line will be over the other line. Okay, just merge on the other line. Okay, yeah. Next question was, a soil sample has specific gravity of 2.7 and optimum moisture content of 16%. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? The options are, the answers are in gram per cc. Okay, mind the units. The options are 0.185, 1.896, 1.885, 1.785. A soil sample has specific gravity of 2.7 and OMC is optimum moisture content of 16%. What is the theoretical maximum dry density in gram per cc that can be achieved for this soil? I'm asking you about the theoretical maximum dry density, MDD. The options are 0.185, 1.896, 1.885 or 1.785. Next question, another numerical. It has 3 parts. Just write down the question first. A cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard Proctor test. The specific gravity of this soil is 2.65. The questions are, determine the void ratio of the soil, part A. Determine the void ratio of the soil. Part B, find out the degree of saturation. And part C is, find out the maximum dry density it can be further compacted to. Okay, someone has joined just now and Shakir was asking for the first 2 questions. I'll just go through the question once, okay, after this. The question is, a cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard Proctor test. The specific gravity of the soil is 2.65. Determine option A, part A, the void ratio of the soil, part B, the degree of saturation, part C, the maximum dry density it can be further compacted to. Has everyone written down the questions? All the questions? Abhishek, Sagar. If you have completed, just yeah. Okay. Okay. So I believe everyone has written down the questions. Now, Shakir, you are asking for the first two questions, right?
Yes, sir.
Okay. The first question was okay. Yeah. First question was factors affecting compaction of a soil are. What are the factors which affect the compaction of a soil? The options were water content, soil type, compaction energy, or all of these. The factors which affect the compaction of a soil are water content, soil type, compaction energy, or all of these. Next question. This is a multiple select question, so more than one answer will be correct. For a same soil type, the effect of heavier compaction is 2. It means if we give more compaction energy, what will happen to the soil? Decrease the optimum water content, decrease the maximum dry density, decrease the effective shear stress, increase the maximum dry density. Okay. Let's go to the second, third question one. Water content used in field compaction is called. These are the options: optimum, field, placement, or natural. Compaction control in the field consists of determination of water content, dry density, degree of compaction, all of this. Okay, so the person who has joined late, Anshuman,
Yes, sir.
yeah, so you need to wait because I have already discussed the questions. I have already told them the questions. Okay, so should I tell the questions again? Can you write down now in 5 minutes? Because you have joined at the end, right? Hello, speak up.
Okay.
Okay, just write down fast. Compaction control in the field consists determination of vibratory rollers are useful for compacting which kind of soil? Cohesionless soil, crushed rocks, gravel, or clay soil. Next question was clay particles compacted on dry side of OMC will have which kind of structure? Single grained, dispersed, honeycombed, or flocculated structure. I mentioned dry side of the OMC. Highway embankments on cohesive soils should be compacted on the dry side. The reason is we have low permeability or reduced pore pressure or high strength or none of these. Plasticity needle is used to determine which following properties: plastic limit, penetration resistance to control field compaction, penetration value of bitumen used in road construction, or swelling in black cotton soils. Plasticity needle is also called Proctor needle if you don't know the actual name. Well-graded coarse grained soil attain much higher density and lower optimum moisture content than fine grained soil. The statement is true or false you have to mention. The variables concerning the method, I just repeat the question. Well-graded coarse grained soil attain much higher density and lower optimum moisture content than fine grained soil. Okay. The variables concerning the method used to compact a given soil include the manner of operation, weight of the equipment, area of contact, or time. These are multiple select questions. More than one will be correct. Pneumatic tire rollers suitable for which kind of soil? Gravel, cohesive soil, sand, or all of these? The compactive effort in modified Proctor test is roughly 4.5 times that in the standard Proctor test. Is true or false? You have to mention. Number of blows required for compacting each layer in a compaction test: 30, 35, 45, 25. Which soil has the highest optimum moisture content? Sand, silt, gravel, clay. Mention. The line showing dry density as a function of water content in the absence of air voids is called zero saturation line, no air voids line, maximum compaction line, or saturation line. Modified Proctor test, the soil is compacted in how many layers? 2, 3, 4, or 5 layers. To avoid large swelling pressure under pavement, the soil is compacted on the wet side of OMC, at OMC, dry side of OMC, or none of these. I am audible, right? Anshuman, Shudipto, hello.
Hello. Yes, sir.
Yes, okay. Can you note down the question or I'm going fast?
Yes, sir.
Yeah, okay. I'll give you some time to solve these questions. 95% saturation line and 5% airwords line are same or different, might be same or different, or are the same under the same constant moisture content. This was the numerical. If you want to take a photo, please take a photo fast. Soil sample has specific gravity of 2.7, optimum moisture content 16%. What is the theoretical maximum dry density that can be achieved for the soil in gram per cc? 0.185, 1.896, 1.885, 1.785. And last question was, a cohesive soil yields a maximum dry density of 1.8 gram per cc at an optimum moisture content of 16% during a standard Proctor test. The specific gravity of the soil is 2.65. Determine part A, the void ratio of the soil, part B, the degree of saturation, and part C, the maximum dry density it can be further compacted to. So I think you have written down all the questions. I'll give you 10 minutes time. You can solve it. Okay. We start at around 6 o'clock. Okay. Solve it. If anyone has finished solving, they can drop a message in the chat box or can raise their hand. Okay. Is it clear? Okay. Have you completed all the questions? Some questions completed. Do you need some more time, or do you need to? We need the solutions of the rest, because I'm giving you 10 minutes. Solution. Okay. Okay. I'll start discussing the answers right now. Okay. Yeah. So the first question was factors affecting compaction of a soil are. What is the answer?
All of these.
All of these. Yes. Why? How will each affect the compaction of a soil? First of all, water content, you all know, because you add moisture to the soil and then you start compacting, right? So it depends on the moisture content, whether how much moisture content is required for reaching the maximum dry density is called the optimum moisture content. Water content, you all know. Soil type, how will soil type affect the compaction of a soil? Anyone?
Soil type.
Shakir, I think your mic is causing some problems. You can write in the chat box. How will soil type affect the compaction of a soil? Anyone else? Particle size gradation, it depends. Well graded soil or poor graded soil, because the interlocking nature of soil particles, that is an aspect which is required to be kept in mind while compaction of a soil, right? Also the particle size, because some particles will have more specific area, some particles will have less specific area. The particles which will have more specific area, those particles will be requiring more amount of water. Unique index property, yeah, unique index property, but among those index property few are required. You are right, Sagar, you are right, each will have unique index property. But first of all, particle size, specific surface, all these properties required are need to be kept in mind basically for compaction of a soil. And third option is compaction energy, that you all know the more compaction energy you give, the better compaction will be executed in a particular soil. Okay, so the first question, the answer will be fourth one, all of these. Just a second, I just take the answer. Yeah. Next question. For a same soil type, the effect of heavier compaction is 2. What is the answer? Anyone? There's a multiple select questions. They can be more than one options correct. What are the answers? So what is the answer? What is the answer, Anshuman? A and D, Sagar Yadav. A is decrease the optimum bottom moisture content, yes, and D is the increase in maximum dry density. Okay. Okay. Anyone else? Any other answer? Yes, Sagar, you are correct. A heavier compaction effort will decrease the optimum moisture content and it will increase the maximum dry density. Had I said over here that it increases the effective shear stress, then that would have been a problem, because if you compact soil and make it into a close packing arrangement, then the grain to grain transfer of load might increase, and that might increase the effective shear stress. But I have mentioned over here decrease the effective shear stress, because the shear stress chapter is not yet been covered. So I just give it a straightforward question of compaction. So yes, the effect of heavier compaction is to decrease the optimum moisture content and increase the maximum dry density. Good. Clear, all of you? I'll go to the next question right now. The water content used in field compaction is known as. What is the answer?
Place.
Shakir. Placement water content, right? Yes, I think you are saying placement water content, and the placement water content is the right option. This is indeed called placement water content, because this placement water content is responsible when we are when we are compacting soils for any kind of infrastructure construction or roads or dams. Then this placement moisture content, whether it will be on the dry side of OMC or on the wet side of OMC, that is important. Okay, so this water content in the field compaction is known as placement water content. Right answer. Next question is, compaction control in the field consists of determination of. What is the answer? Apart from Sagar and Shakir, someone else answered this time. Anshuman, Abhishek, Shudipto. What is the answer? Compaction control in the field consists of determination of. Anyone?
So,
Yes. What is the answer?
all of these.
All of this. Okay. What is degree of compaction? What is degree of compaction? What is the definition of degree of compaction? Anyone? Okay, if you don't speak, I'll just go along with you. Dry density achieved when it is divided by the maximum dry density in the laboratory, that gives us a degree of compaction. So control on compaction, it means what are the attributes which we are trying to take control into. Okay, so we should be careful about the moisture content at which the soil is compacted. We should keep in mind the dry density which we require for that particular infrastructure or field condition, and along with the dry density achieved, from the dry density achieved we can easily get the degree of compaction. So all of these is the answer, because the second option and the third option are basically the same thing, they are related. Okay, so water content and dry density are the mainly two parameters. Clear, all of you? I'll go to the next question. Vibratory rollers are useful for compacting. What is the answer? Either you say
Gravel.
gravel. Okay.
Coarse
Yes. Which option?
coarse grain gravel.
Coarse grain soil. How are coarse grain soil named in another term? What is another term for coarse grain soil? Sands and gravels. Which strength property is absent in them? Do they have cohesion? Do sand and gravel have cohesion?
No.
So this, what is the answer? If your mic is not working, you can just write down in the chat box, but interact. If you stop interacting, then it will be difficult for me to understand whether you are giving the answer or not. If you don't give the answer, I'll just go along. But if you are giving the answer, then give it a proper way. Either you,
Just like granular soil.
which soil?
Granular.
Granular soil. Which option among these? Cohesionless soil, crushed rocks, gravel, and clay soil. Which option among these? Yes. D is correct. Clay soil. Vibrated roller is for clay soil. Who has given D as option? Abhishek Sharma. No, D is not correct. The correct option is cohesionless soil. Vibratory roller are used for cohesionless soil because the vibration can break the internal structure, clay mineral structure in the cohesive soil. So this is only used for compacting cohesionless soils. Okay. Now, next question. Clay particles compacted on the dry side of optimum moisture content exhibit which structure? What is the answer?
Flood.
Shakir, you don't use a mic, you just write in the chat box. Your mic is not working, I think. You have spoken many times, but it was not clear. Every single time it was hazy. Your voice was. Yes, Shakir is saying flocculated. Anyone else? What is the answer? Yes, clay particles, when they are compacted on the dry side of optimum moisture content, they exhibit. Ashok Saini is saying dispersed structure. Okay. No, Ashok, you're not right. Shakir is right. He has said flocculated structure. Flocculated is the right answer. It is because why? Shakir, can you tell me why it is flocculated, and under what condition it will become dispersed?
The soil particles are in it will
Your voice is breaking. Okay, I'll tell the answer. See, we are dealing with clay, right? Clay particles. So when we say clay particles, if we compact them on the dry side, that means the water is less. When there is less amount of water, the orientation will be less because it is a fine grained soil. It will be less oriented. When the soil is less oriented, the structure is called flocculated structure. Now, as we go on adding more water and the moisture content, the clay particles go beyond the optimum moisture content, or it goes on the wet side of the optimum moisture content. Okay, at that point of time, the soil particles becomes more and more oriented, and that oriented structure is called dispersed structure. So when it is compacted on the dry side of the optimum moisture content, it will always show, clay particles will always show flocculated structure. Okay, is it clear, all of you? Don't answer, I'll just take it is clear and go to the next question. Next question is, highway embankments on cohesive soil should be compacted on the dry side of the optimum moisture content to achieve which property? What is the answer? Low permeability. Highway embankments, what is the primary property, primary feature which they require? Highway embankments on cohesive soils. Anyone else? So what is the answer, Shakir? Low permeability or high strength? High strength, okay. Yes, high strength is the answer because it needs to resist deformation. Even if it has low permeability, it doesn't mean that it can resist deformation. So compaction on the dry side, that means it will have more strength, and it can, yes, high strength, it can resist deformation to a much more extent, greater extent. So to achieve high strength, embankments on cohesive soil should be compacted on the dry side of the optimum moisture content. The answer is high strength. Okay. Now, next question. Plasticity needle is a very easy question. What is the answer? What is the answer? Plasticity needle or Proctor's needle? Why it is used? Anyone? Okay. The answer is penetration resistance to control field compaction. Plastic limit you already learned is not the answer. Penetration value of bitumen used in road construction, we use a different instrument altogether. Swelling of black cotton soils is not used to measure by using the Proctor's needle basically. So it is penetration resistance. But penetration resistance I have given two penetration resistance. Penetration value and penetration. Okay, field compaction. Yes, penetration resistance to control field compaction is the answer. Plasticity needle also called Proctor's needle. Okay, how much the soil is giving resistance to the penetration during compaction is called penetration resistance, and that is being measured by using Proctor's needle or plasticity needle. Yes. Next question, true false. Well graded coarse grained soils attain much higher density and lower optimum water content than fine grained soil. True or false? What is the answer? True or false? True. True. Yes. Why true? Just what is the basic reason? I've already mentioned about a particular property of fine grained soil in the beginning, because of which this statement is true. Can anyone recall that? Which soil will have higher specific surface, coarse grained soil or fine grained soil? Which
Fine
soil?
grain soil.
Fine grained soil. Okay. So if a soil has higher specific surface and a soil has low specific surface, which soil will need more amount of lubrication during compaction?
Uh,
Yes. Fine grained soil or coarse grained
Fine grain
soil?
soil.
Fine grained soil will need more water for lubrication during compaction, right? So if fine grained soil they need more lubrication, okay, then can we say that by adding more and more amount of water, okay, it will the moisture content if it increases, then the optimum moisture content will also increase, right? The same graph. But in case of coarse grained soils, they have low specific surface, and also I have mentioned over here well graded. What does well graded mean? What is the meaning of well graded?
Size of soil particles are available.
Yes, particles of almost all, not all sizes, almost all sizes are available. So if that is the condition, then it will have much better interlocking property, right? Coarse grained soil which are well graded, isn't it? And if a particular soil has a high interlocking property, well graded soil, then it will be very easy to compact that soil using less amount of moisture, less amount of water. So yes, the answer is true. Well graded coarse grained soil attain much higher density and lower optimum moisture content than fine grained soil. First of all, because fine grained soil has more specific surface, they require more water to lubricate themselves during compaction. And secondly, well graded, that means it has particles of almost all size range and it has a better interlocking property, because of which it requires less amount of water. Clear? Next question. The variables concerning the method used to compact a given soil include, what is the answer?
Sir, all factors.
Who was speaking? All the factors.
Yes, sir.
All the factors. Okay. Manner of operation I understand. Weight also I understand. Please explain the area of time, area and time. Area of quantity and time. Can anyone explain? Time also it's okay because if you apply the weight of the equipment for more time, it will compact more, right? Now, what is the deal with the area of contact? Anyone? For the same weight of the equipment, if the area is less, then what attribute will be more? If the area is less, then the pressure will be more, right?
Yes, sir.
Yeah. So in that case, area of contact is important, an important aspect, variable concerning the method which has been used to compact a soil. So manner of operation, weight of the equipment, area of contact and time. All the four parameters are important when you are concerning the method of compaction. Okay. Next question. Pneumatic tire rollers are suitable for. What is the answer? What is the answer?
Cohesive soil.
Cohesive soil. Okay. Anyone else? It is not like vibratory I have given for cohesionless soil and I'll give another one for cohesive soil. These pneumatic tire rollers they go by pressure plus kneading effect. Okay, pressure and kneading effect. These two properties are beneficial for all kinds of soils, whether it is cohesionless or cohesive soil. So pneumatic tire rollers are suitable for all types of soils: sand, gravel, clay, silt. Clear? Kneading is iterative pressure. You're not
Sir,
giving it constantly. Yes.
this for fine grained soil is this is a mainly used pneumatic tire rollers are used. So out of these four, we should select the fine grained one as a
Pneumatic
gravel are
tires.
well
No,
graded.
I have written suitable for. Mind the question. I have not said pneumatic tire rollers are mainly used for. It can be mainly used for fine grained soil. That is a different thing because for coarse grained soil we have vibrators. But I have written they are suitable for because of their pressure and kneading effect. That is iterative pressure effect. These kinds of rollers are suitable for all kinds of soil. Obviously, if you are using vibratory rollers for gravels and sand, obviously you will not use them for cohesive soil. You will use pneumatic tires for cohesive soil. But it is suitable for all kinds of soils. Okay,
Okay, sir.
do you get the point? This question was
Yeah,
suitable
sir.
for. Okay, so suitable for all types of soil. If you don't have vibratory rollers for what to say cohesionless soil, you can use this kind of machine also. Okay, next question. Yes. The compactive effort in modified proctor test is roughly 4.5 times that in the standard proctor test. True or false?
True.
True. What is the compactive effort in the standard proctor test?
4.56.
What is the compactive energy? 4.5. What is the compactive energy in kilojoule per meter cube? For standard, it is 595, right?
593.
Yeah,
Yeah.
around 590. 595 kilojoule per meter cube. What is for the modified proctor? 2764, something like that, right? 2764.
2704.
2672, yeah. Around 2700. Right, the exact thing, 2674. Yes, around 4.49 to 4.5. So, the statement is true. Okay. Whatever book you get, whatever book you have, standard textbooks, try to remember these values. It's very important. The compactive energy used in standard proctor test and modified proctor test. Next question. It's a very easy question. Number of blows required for compacting each layer in soil. What is the answer? Anyone? Very easy question.
25.
Yes, it's 25. Basic general
Yeah.
question. This is 25. Among the following, which one has the highest optimum moisture content?
Sir, clay.
Clay has the highest optimum moisture content. Why? I think I have mentioned this property of clay before also. What is the property we are talking about over here? Anyone? Specific surface, right? I think CH. Yes, high plasticity. And this is for CL. What is CH and CL? Have you seen this graph?
Yes, sir.
Yes, sir.
Yes. What does this mean? What is the meaning of this graph? What is CL and CH?
This is nomenclature of the particles.
What does L mean?
Low plasticity.
Low plasticity, and H means high plasticity. So clay which has high plasticity, that means it is very much plastic in nature, requires more water to compact it and bring it into a closed packing form. Hence, and because of this specific surface, it needs more water to lubricate itself. Hence, it is having the highest optimum moisture content. This is the moisture content, this is the dye density. Highest optimum moisture content with the lowest dye density. Clear? And see, as I have mentioned in the in the first two and four statement, well graded coarse grained soil have high maximum dye density. You can see over here gravel, well-graded gravel and well-graded sand, they have high maximum dye density with very low optimum moisture content. Clear everyone?
Yes, sir.
Yeah. If you can't understand anything, you can just stop me and ask me, or just can drop a message in the chat box. Okay, next question. The line showing dry density as a function of water content in the absence of air void is called. What is it called?
No air void line.
I'm asking about the actual terminology. Anyone else?
Zero air void line actually.
Okay, so among these, which is the answer?
Saturation line. Means
Sa-
zero air void line means saturation is 100%. So
Yeah, very
saturation
good,
line.
very good. Yeah,
Zero
saturation line.
saturation line.
Not zero saturation line. Who is it? Zero
Saturation.
saturation line is saturation is zero. That means it has air voids. What is the answer? A or D?
D. Saturation line.
Yes, saturation line. When it has, in the absence of air void, there is no air voids. That means all the voids are filled with water. So the soil is saturated basically. So it is also called saturation line. This is also called zero air void line. Zero air void. Okay, clear?
Sir, what is difference between no air void line and zero air void
I
line?
have asked about the actual terminology. The line is actually called zero air void line and saturation line. There is no line in soil mechanics which is called no air void line. Okay, these are some made up statements. Okay, all the three are made up. Zero saturation line, no air voids line, maximum compaction line. It is true that no air voids absence of the same thing, but the line is called zero air void line. I have told what it is called. The actual terminology I have asked. Okay, clear?
Okay, sir.
Yeah. So actual terminology you need to remember sometimes. Yeah. Next question. In modified Proctor test, soil is compacted in how many layers?
5 layers.
5 layers. And how many layers is needed for the standard Proctor test?
3.
So
Yes.
3.
3 layers needed for the standard Proctor test. Okay. Right. To avoid large swelling pressure under pavement, the soil is compacted. What is the answer?
Wet of optimum.
Why?
Sir, at wet of optimum volume deformation.
What is stronger? Volume.
So some volume deformation is will occur.
I can't get you. Please explain once again. Your
I
voice
can't.
is not clear. At weight of optimum, yes.
So the volume deformation will occur.
Deformation will occur.
Volume deformation, sir.
Volume deformation at the weight of optimum.
Yes, sir.
Yes, so it is not specifically only volume deformation which you're talking about. If it is compacted weight of optimum, that means it has more moisture, it has more water. The soil has more water than the optimum moisture content, right? So in that case, which is already being compacted with more amount of moisture, then when there is no space for any more amount of water to exert any excess amount of pore pressure, right? Soil is already having the pores are already being filled with water. So if the water cannot cause any ingression or effect of pore pressure in the soil, then there will be no swelling pressure, right, under pavements, because it is compacted, already compacted weight of the optimum. This is the graph, and this is the moisture content. If I'm compacting it here, dry of optimum, okay, that means it has less amount of moisture content, and by that means the pores are still empty, it has air, and if water enters the pore, it can cause swelling pressure, right? And if I just compact it over here, I've increased the moisture content, isn't it? So more and more number of pores are getting occupied with water, so there is less chance over here of water to cause accidental increment in the pore pressure, which might lead to increase in swelling pressure. Got it? Any doubt?
Sir, explain once again.
What have you understood till now? Hello, who was that? Shakir. Okay, so if I am compacting the soil at this point, okay, this is the dry density. I'm compacting at this point. This is having less moisture content, right? Suppose this is 5%, 5% moisture content. That means the water in the soil is low. I'm talking about the same mass of soil. Hello, okay. Am I audible now?
Yeah, it's okay now, sir.
Yes. So I'm talking about the same mass of soil. Suppose the mass of soil solids is ms. For the same mass of soil, if I'm compacting the soil at this point, 5% moisture content, the amount of water it has over here is obviously less than the amount of water it has over here, right? If it is suppose 15% moisture content, isn't it? In the same mass of soil. So if the moisture content is more, already the moisture content is more, that means the soil has been better compacted, not in terms of dry density but in terms of water, because if water is already present in the pores, that means any accidental increment in swelling pressure or pore pressure cannot happen. And obviously the pore was less filled in this case and it is more filled in this case, right? When you are given a dry sample of soil, okay, and you place it in water, and you are being given a wet sample of soil and place it in water, which will swell more? Hello, are you getting my point? Am I audible in the first place or what? Yes,
Yes, sir.
dry sample, because the pores are empty right now. So this is the reason we try to compact soil under pavements, weight of optimum moisture content, because if there is any swelling or shrinkage pressure, then it will develop cracks on the surface, right, on the pavement, on the roads. Hence we go for wet side of the OMC. Clear?
Yeah, sir.
Yeah.
Yes, sir.
Okay, now the next question. 95% saturation line and 5% airwords line, are these same or different? What is the answer?
Same.
Same. Okay, anyone else?
Sir, same under
Your voice is
optimum moisture
breaking.
content.
Voice is breaking. 95% saturation line and 5% airwords line, so you all are saying it is same, right? Hello?
Yes, sir.
Same. Okay, So if 95% and 5% represent the same line, that means the saturation and percentage air voids, they are complementary to one another, right? By saying this, I mean, what is the percentage air voids formula? What is the formula for percentage air voids? Anyone? It is volume of air divided
Vo-
by the volume of voids
volume of
divided by the
void
volume of
into
the soil
surface.
sample into 100, not the volume of voids. Right? And what is saturation formula? Degree of saturation is, what is the formula?
Volume of water divided by volume of void.
Divided by volume of voids into 100. Now look at these two formula. One, I am calculating the volume of air with respect to the volume of the soil sample, and the other one, saturation, volume of water with respect to the volume of voids. So can these two properties complement one another? Can these two properties complement one another? Yes or no? Here we
Yes,
have
sir.
yes. How can they complement one another? If I'm calculating, my basis of calculation is different for percentage air voids and degree saturation, how can they complement one another? Okay, there is another attribute, right? Air content. What is the formula of air content in percentage?
Volume of volume of air divided by volume of void.
Volume of voids. If I want to show it in percentage, it will be like this, right? Air content. Now look at air content and look at saturation. The basis of calculation of air void and water voids, it is same, right, in both of these cases.
Yes, sir.
Volume of voids, I'm calculating on the volume of voids, so it is air content plus saturation, which will give
Is
us a
equal to
value of
1.
1,
1.
or in percentage 100 percentage. If I would have said over here 5% air content line, then it would have been same, but I have mentioned 5% air void line. 5% air void have been calculated on the total volume of soil. Okay, so these two are not the same, hence the answer is different. Is it clear?
Yes, sir.
Clear, everyone? Okay, I'll just quickly go to the numericals. First question, specific gravity 2.7, optimum moisture content 16%, theoretical maximum dry density. What is the answer?
1.885.
1.885, option C, right? How do you calculate this? What is the formula?
Gamma D is equal to G gamma W divided by 1 plus omega G.
The actual formula is G W divided by 1 plus WG by S,
SR.
right?
Yes, sir.
Now S for theoretical maximum dry density, this will be equal
It's
to 1.
100%. 1.
Yes, so if you put rho W is 1 gram per cc, G is 2.7, W is 0.16, and again G 2.7, you get the answer as 1.885, isn't it? Gram per cc, right?
Right.
Yeah, so I believe this was easy. Now the next question. Cohesive soil yields a maximum dry density 1.8 gram per cc, OMC 16%, standard factor test, specific gravity 2.65. What is the void ratio?
at 47.22%.
Void ratio is not calculated in percentage. Porosity is found out in percentage. What is the void ratio? Tell me again.
0.47.
0.4722. How do you calculate the void
Yes.
ratio? What is the formula?
So gamma D is equal
Same
to
by
G gamma
copy.
W divided by 1 plus E.
Gamma D equals to G what?
Gamma W divided by 1 plus
1
E.
plus C. From here, what we get? E equals to G.
0.47.
Say I am using dry density, so use rho instead of gamma because gamma is unit weight, isn't it? G rho W by rho D minus 1, right? This is the formula for E.
Yes, sir.
Yes. So G, you put G over here as 2.65, rho W is 1, rho D is 1.8, and you get the value of G as how much? 0.4722, right?
Yes, sir.
4722. Okay. Now how do you find out the degree of saturation?
So we have formula. This omega G is equal to ESR. We'll find SR.
What is the answer?
That is 89.8%.
89 point.
8%.
Yes, S equal to Wg by E, right? Saturation equals to Wg by E. Now I think this will give you the answer in decimal, right? You have to multiply with 100. You get how much? 89. I'll take two decimal places.
0.8.
79 percentage. Okay, fine. Is it okay? This is the answer, right?
Right, sir.
Yes, very good. Now the third part. C. What is the answer you have got? In gram per cc. What is the formula? Rho max equals to this one you have done in the previous sum only. What is the formula?
Rho D field divided by Rho D max. Degree of compaction.
No, I'm not asking about the degree of compaction. I'm asking about the maximum dry density. What is the formula?
G gamma W divided by 1 plus E minimum.
Again, do not use gamma when asked about density. Use rho. G rho W divided by what? Divided by
1 plus omega g.
1 plus omega g. Only omega g. What is the actual formula of
Omega G by
omega
SR.
g by s? Yes, omega g by s. Now, what are the values? G, what is the value of G? 2.65. Okay. What is rho W? It is 1. What is W or omega? This water content? 0.16, right? Hello?
Yes, sir.
Yes. What is the value of
Yes, sir.
S? What is the value of S?
0.8979.
0.8979. Okay. You use 0.8979 and tell me the answer.
1.79
Gamma D max
gram
is
per cc.
1.79, right? Okay.
Yes, sir.
So
Yes, sir. Gram per cc.
what was the question in part C? See the question. The maximum dry density it can be
It,
further compacted to. If you are using the same saturation percentage in the formula, won't you get the same dry density which you have been given in the question?
Right, sir.
Yes. So what
Yes,
is
sir.
the value of S you should use over here? If you want to further compact the soil and get more dry density, what is the value of S you should use over here?
0.
0. I'm not asking you to suck the soil dry. I'm asking you have some moisture over there. Now what can you do to increase the dry density?
S is equal to take 1.
Yes, in the previous sum only you have done, right? S is equal to 1. If you take S equals to 1, now calculate the value of rho d max in gram per cc.
1.85.
1.85. Okay, wait a second. S equals to 1. 0.16 into 2.65. 2.65 plus 1. 0.65 divided by calculate it properly. What are the values you have taken?
1.86.
1.861, right? 1.8609. 1.861 gram per cc. This is the answer, right?
Yes, sir.
Yes. So is this sum clear, all of you? How you are finding out E and S? You have been given a particular soil condition. Very careful, listen to me. Given a particular soil condition which has the maximum density of this. In this soil condition, you are finding out the void ratio and you are finding out the saturation percentage. Now this is over. This is the particular soil condition which you have been given. In the next condition, you are asked to increase the dry density. How further can you increase? You can increase by increasing by taking S equals to 1. If you increase the degree of saturation, that means you are filling out all the pores. You are filling out all the pores which are being occupied by air. You are filling them out with water. Okay, that will also help you in improving the dry density, right? So if you are filling out all the pores and taking S equals to 1, then you will have the maximum dry density. It can be further compacted, that is 1.861 gram per cc. Is it clear, all of you?
Yes, sir.
Okay. So any doubt, anyone?
No, sir.
Okay. I'll be sharing this PPT with the NPTEL team, and I believe you will be getting from them. Okay. If you have any other question, you can ask me. Otherwise, we can resolve the.
Sir, only videos they are uploading this. No PPTs.
You are getting YouTube videos.
Yes, sir. Their
Okay.
link is there showing, but no PPTs.
You are not getting any Google Drive from them,
No, sir.
but many people have requested for the Google Drive. Okay, you see, even in the videos also you can just what to say, fast forward and see the questions and the answers, right? No need to check the full 2 hours video. Just the question and answer you need. Explanation you've already got.
Sir, one question.
Yes, yes, one question. Who is that? What is the question? Hello. Ashok, if you are speaking,
Yes, sir. Yes, sir.
your
A
voice is
dry soil has
yes, dry soil.
mass specific gravity of 1.35.
Dry soil, specific gravity. You are asking me a different question.
Yes, sir.
Is this question given to you in the assignment?
No, sir. My workbook question.
Actually, I'm allowed to resolve your doubts, but I have not seen the assignment questions. So, okay, you ask me, what is the question? What are the properties? A dry soil,
Mass specific gravity 1.35,
mass specific gravity. Okay, G equals to 1.35. Okay,
and if the specific gravity of solid 2.7,
specific gravity of soil solid. Okay, this is GM, this is GS, 2.7. Okay,
then void ratio.
then find out the void ratio. So GM is given, GS is given, find out the void ratio. Okay, from GM you can find gamma D by gamma W, this is gamma S by gamma W, gamma D equals to gamma T, gamma D plus W. Okay, you have a standard textbook, right?
Right, sure.
Which textbook you have?
SSCJ.
Not SSC JE, soil mechanics textbook. Which textbook you have? Soil mechanics.
Sir, my book is not here.
What?
Screenshot question.
Which college are you from?
Pratap College, Shikar.
I am asking about any standard soil mechanics textbook. Which one you have?
This time is nothing book, sir.
Okay, see, for solving this kind of question, you need to understand the concepts first. What is mass specific gravity? What is specific gravity of soil solids? Which one is taken generally? What is the formula? And using the formula and using their index properties, how can you relate them? And then only you can solve it. So I'll ask you, don't solve SSC JE question. You first study the concept from a good soil mechanics book, that is BC Punmiya or Gopal Ranjan Rao, any kind of book. If you understand the English properties properly in a good depth, you can solve these questions. Okay. For example, in today's question, the formulas which I have given, the sum which I have given, they are from the previous year's gate question which have been mentioned in the BC Punmiya book. Okay, previous year's gate or EAC questions I have taken them, but you need to understand how, from where this formula is coming. This is formula of rho d, right? Rho d. What is the formula? Austin formula of rho d? Rho d equals to what? G rho W divided by 1 plus E, isn't it? And E, the formula of E is Wg by S. Hence, we are getting this formula. So, in this properties has many formulas. Yes, BC Bunyabo you can follow. And okay, the one who has asked this question, he has left the meeting. Okay, so if there are no more questions, no more doubts, I will just resolve the meeting. Is it okay? Yes, there are many books, Aurora and BC Bunyabo, but standard textbook you need to understand the concept.
Thank you, sir.
Yeah. Okay. Thank you for attending the class.